Welcome to this presentation of Introduction to Blockchain Technology. Again, this is a presentation of coding boot camps. Distributed blockchain networks. And this is information about our instructor, which we have covered. So what we have discussed so far are consensus algorithms. We discussed hashing. We discussed mining, blockchain mining. We discussed Bitcoin. We also discussed the blockchain and the blocks and how blocks are how blocks are filled with transactions. So right now we are going to talk about the blockchain distributed network. So every blockchain network is distributed in some way. You may have heard the term distributed ledger technologies, and that's an updated name for blockchains, distributed ledger technologies, because there are some blockchains out there, particularly Hyperledger and Corda, that are not constructed in the same way that like a Bitcoin network is constructed. In Bitcoin, there's just one type of node. In Hyperledger Fabric and in Corda, there are specialty nodes that perform specialty jobs. However, though, the ledger always needs to be the same. So every blockchain network has some level of distribution. You could say that besides being a ledger, a blockchain is a supercomputer. So it's the sum total of all the processing power of all the nodes. And that's been talked about. We've heard the term, especially for Ethereum, of an operating network instead of an operating system. That we are a term that we're all familiar with and all comfortable with. So applications run on the operating network much in the same way that applications would run on your desktop or laptop on that operating system. Blockchain, again, is community-based. Nobody owns it. There is no central authority. And all nodes on most networks are equal peers. Blockchains all run, no matter what they are, on a distributed network. And if we think about the original networks, so when networks were first assembled, all the networks were centralized. So when we say centralized, the network, they had a focal point in which all of the nodes communicated. And every node communicated with that focal point, and then messages were relayed from the central focal point to the receiver node. So it was always to the central node or central focal point back to the intended node for the message. The central node was the weak link in a centralized network, because if that went offline, the whole network went down. The blockchain runs again on a distributed network, and you can see here what a centralized network looks like. So there is this central focal point, and all of the nodes here on the network communicate through that central focal point. So these types of networks, as you can imagine, are very vulnerable to attack, because the only point you can bring down the whole network by just attacking the focal point, the central focal point. Blockchains, again, use decentralized, meaning that the networks or decentralized networks also make use of the focal point, but there are many focal points. So it's almost like a network of centralized networks. The nodes that connect to the focal point are called leaves, and the leaves have a primary focal point, but they can also move back toward a different focal point. So the leaves send their messages to their own focal point nodes, and then they also send the messages over to the appropriate receiving focal point node. And again, decentralized networks have more redundancy, so they are more difficult to attack. Decentralized networks do have central authorities, and even though they're less vulnerable, they are still vulnerable to attack. So we can see here with a decentralized network, we have several focal points. So if any of these focal points, any one of them would go offline, we would have other focal points that come back on. And if this node needed to communicate with this node, it would be relayed through their focal points. So again, they could have multiple authorities. So they're not distributed networks, as they do have this concept of the focal point. And fully distributed networks have no central focal points or central authorities. Each node or computer on a distributed network communicates directly with the others in a peer-to-peer format. And since there are no central nodes, a distributed network is the least vulnerable to attack. So, because if any node goes offline in a distributed network, another one can be just brought back on to take its place. So distributed networks are considered to be the most resilient, and there are no single points of failure. And again, they are less vulnerable to attack. So here we see a distributed network here. There are no focal points. Every node is a peer. So if any one of these goes offline, another node can step up to take its place. And there are no central authorities on a distributed network. And with the blockchain running on the distributed network, new transactions and blocks are broadcast across the network and using something called a gossip protocol. So essentially, the messages just move through one node to another or several to another. And with no central authority, all the nodes will have to synchronize the ledger. So we need some way to come to consensus again. We've already talked about consensus, and resynchronize periodically. Each ledger on each node will return the same data when queried. So that's important, because even on a network that has this level of complexity, there is still supposed to only be one ledger. So that's why we say that each node will return the same data. And again, centralized architecture would not be able to handle the transactions anyway close to what a distributed network can handle it for the blockchain. If a centralized database were attacked, account holders would have a chance to lose whatever cryptocurrency they are attempting to transact. So that distributed ledger is many copies of the ledger, so fraud is less likely to succeed. So if we take a look on here again, if a hacker attempted to attack just one of the nodes, it would get taken offline and then get replaced with the correct copy of the ledger. So again, it is our blockchain is hashed, and then it's stored on a distributed network, so it's much less vulnerable to attack. You hear the term sometimes unhackable, and I'll leave that up to everyone really to decide whether this is really unhackable. It is more apparent, hack apparent. So then steps can be taken to quickly repair any kind of damage that a hack has caused. So again, public blockchains are not owned by anyone, and blockchain is a distributed ledger that runs on a peer-to-peer network. The centralized network has a single focal node. Decentralized networks have several focal points, and distributed networks are completely peer-to-peer, have no central focal points. Please review the assessment. And again, for more information, please consult your learning materials. And if you're interested in more training, again, please consult your learning materials. And next, we'll review how a blockchain differs from a database. So they're both repositories of data. Blockchain's a repository of data, and a database is a repository of data. The way they manage data and the way they process data is quite different. Again, thank you.